All right, so I'm going to try to do this as 5-2 because my videos did not work because my phone was full, so I had to delete some things. So doing dividing by polynomials, we're looking at dividing the polynomials first by a monomial. This is an Algebra 1 teak, where we're just basically simplifying. So I start with the problem looking like this. I can actually separate each one individually to simplify and divide. So when I divide 6 by 3, I got 2. X to the 4th divided by x. This is subtracting our exponent, so that would be x to the 3rd. And then 3 over 1 would be y squared. And I followed that same suit each time. So 12 divided by 3 was 4. X cubed divided by x was x squared. And y squared divided by y was a single y. And then the last thing we have here is when we're subtracting is 18 divided by 3 was 6. X squared divided by x was x. And the two y's divided out, what we call canceling. And so I did that for the next two just to show you that it can be written this way. It can be written with it to the -1. It still means the same thing. Or it can be written with the division sign, again, still meaning the same thing. Okay. All right, on this page, we're getting into actually long division, old school long division, like we used to do with numbers, except for now we are using polynomials by binomials, and we'll even look at them with polynomials by trinomials. So to do long division, I'm going to zoom in on this first one here. When we're doing long division, we're taking the divisor and dividing it into the dividend. So to do that, I have two terms here. So I'm going to be looking at these first two terms here. And I'm going to actually focus in on the first term. What can I multiply x by to get x squared? So we determined that would be x. So x times x gives me x squared. X times -5 gives me -5x. So just like we used to do, I'm going to subtract that line from the line above. So x squared minus x squared gives me 0, and 3x minus -5x, so 3x plus 5x gives me the 8x. And just like we used to do, I'm going to bring down the 40 here, the -40. Okay, so I'm back to the same thing. What can I do to this x to make it 8x? Well, I can multiply by +8. So 8 times x is 8x, and 8 times -5 is -40. So I'm going to subtract that. So 8x minus 8x is 0, and -40 minus -40 is also 0. So I do not have a remainder here. And I did that same thing through the second one. We were dividing into x minus 3. So there's no difference here than what I did when I described the steps here. This one, just pointing out when it's to the -1, it means the same thing. It's still the divisor. But I want to point out that it is okay to rearrange things based on the commutative property. So 2 minus a is the same thing as -a plus 2. I want to always make sure things are in standard form or descending order. So if I have an a and then a constant, so it should be like a cubed, a squared, a, and -9. I also need to make sure that there's no missing parts. If there's any missing parts, I'm going to have to put in a 0 coefficient. So I did the same steps here, but when I got to the end, I got 15. 15 is a remainder, and if you remember back in the day, you put your remainder over your divisor. So that's what we did here, 15 over, and I went back to the original one, 2 minus a. So just so it looked like the original problem. So my final answer was -a squared minus 4a minus 12 plus 15 over 2 minus a. For this problem, for this example problem, I want to point out that while I have r cubed, r squared, r, and no r here, I don't have that same flow going on here. So I skip from r squared to no r. Therefore, I'm going to have to use this 0r term to hold that position. So looking here, I'm going to be dividing by a 3-term trinomial, which means I'm going to be dividing into the first 3 terms. So my first piece will go above the 3rd term. And I'm still focusing in on those first terms when I do that. So what times r squared will give me r cubed? And we said that would be a single r. So I do r times r squared gives me r cubed. R times 0r gives me 0r squared. And then r times -1 gives me the negative r. So now I can subtract this line. So r cubed minus r cubed is 0. 6r squared minus 0r squared is 6r squared. And negative r minus negative r gives me 0 r's. So still carrying on with 0 r's there. And I've got to bring down the -4. So again, I'm looking at r squared and 6r squared. What can I multiply r squared by to get the 6r squared? And we determine that to be 6. So 6 times r squared is 6r squared. 6 times 0r is 0r. And 6 times -1 is -6. So when I subtract these, I get 6r squared minus 6r squared is 0. 0r minus 0r is 0. And -4 minus -6 is a +2. So now I have a remainder again. So I'm putting that over the original divisor. I don't use the one with the 0r in there. I go back to the original divisor. So my solution here is r plus 6 plus 2 over r squared minus 1. We did another one that did not have a need for a 0 position. But we did the same steps. This time it did not have a remainder. The next thing we looked at was the synthetic division, and you can use the synthetic division on everything that was on the homework if you need to. But I recommend practicing that long division on some of them. You're going to write the coefficients of the dividend so that the terms are in descending order, just like we've been doing with our long division. You're going to write the constant of the divisor r, which is in the form x minus r, in a box outside step 1, and I'll explain that more when we're looking at the examples. You're going to bring down the first coefficient, multiply the coefficient by r, and write the product under the second coefficient. Add the product and the second coefficient, and repeat steps 4 and 5 through all coefficients. Your answer is the polynomial of 1 less degree using the new coefficients. All right, so the steps to synthetic division. So we're going to look at the first problem. The first thing is you need to make sure that they are written in the descending order and that everybody's taken care of, that you have every number. So I have x to the 3rd, x squared, x, and no x at all, right? X and no x at all. So I'm good there. I'm going to write those coefficients here first. So I have 2, -13, 26, and -24. And then recall that this is in the form x minus r. So r is just the 4. It's kind of like that h that we dealt with earlier. It is kind of an opposite look. So x minus 4, I'm actually going to use +4. All right, so now I'm going to bring down the first coefficient, and then I'm going to multiply. 4 times 2, that gives me 8. Now I'm going to add these two together. I get -5. I'm going to multiply again. 4 times -5 gives me -20. Add those two together, gives me 6. Again, over here with 4 times 6 gives me 24. And -24 and 24 make 0. So I have no remainder. And now I'm going to use these as my new coefficients. And remember I said it's going to be 1 less than the degree than the polynomial that's the dividend. So x to the 3rd here, my new one's going to be x squared. So I have 2x squared, and bringing this down, minus 5x, and I'm going in descending order, and then plus 6. Okay, same thing here, except for this time I went from 4 to 2 to 1 to 12 to none. So I needed to put 1 in for the x cubed. So I've got a x cubed represented with a 0 here. Again, remember that this is kind of opposite look, so plus 2 actually means negative. So I bring down the 4, and I go through all the same steps, and this time I ended up with a remainder. Still doing the 1 less than a to the 4th, so this will be a to the 3rd, and using these as our new coefficients. So 4a to the 3rd minus 8a squared plus 18a minus 40. The remainder works the same as it did earlier. It's 92 over the divisor. So the divisor was a plus 2, so it's 92 over a plus 2. These last two examples were the same way. I did let them practice one here. But then here I have an example where I'm dealing with a number in front of x. As you can see, we had to divide the whole problem by 3 to get rid of that. So now I'm dealing with all these crazy fractions. So if you don't like fractions, I recommend doing long division for these. If you don't mind fractions, then please try this. So you end up with the fractions, you follow the exact same steps, but if you end up with a fraction as your remainder, there is one last thing you have to do, and that's simplify out the fraction. The reason the way we did that is I took 2/3 and it was divided by x plus 1/3. Well, if you remember in the very beginning of that problem, I said 3x plus 1 divided by 3 gave me the x plus 1/3. So I'm going to change that back to the 3x plus 1 over 3. They're equivalent. I can do that. So now I have the 3x plus 1 over 3. And the way we divide fractions is to copy, change, flip. So I've copied it, changed to multiplication, and I flipped that second fraction. The 3's will cancel, and I multiply top times top, bottom times bottom. So I'm left with 2 on top and 3x plus 1 on bottom. So now I can rewrite my new polynomial, but this time instead of having a fraction over that, I now have 2 over 3x plus 1. And that's the end of 5-2.